In this lesson, we'll be thinking about points, lines, and planes, and other foundational geometry concepts. Two essential questions are, how do defined terms and undefined terms relate to each other? What is the difference between a postulate and a theorem? Let's start with some terms and their definitions. Geometry, the study of relationships, characteristics, and measurements of points, lines, angles, surfaces, and solids. A point references a location in space. It has no length, width, or depth, and therefore has no dimension. A line is a collection of points arranged in a straight path. A line has no thickness, but it does have direction and infinite length, and therefore has dimension 1. A line has arrows on both sides. A plane is a flat surface that has infinite length and width, and therefore has dimension 2. A plane has no thickness. A circle is a shape consisting of a set of points that are equidistant from a special point called the center. Now notice in the word circle, we included in the definition another word, point. There are three undefined terms, points, lines, and planes. All other defined terms in geometry are based on these three undefined terms. So we'll look for the definition of terms and we'll see how they relate to points, lines, and planes. Let's start with the word ray. Ray is a part of a line that extends infinitely in one direction. Let's continue with our definitions. End point, a point at which a line, segment, or ray ends. Segment is part of a line that consists of any 2 points on the line and all the points in between those 2 points. A segment has specific length and can be measured. Angle, 2 rays that share a common point called a vertex. Collinear, points that lie on the same line. Coplanar are points or lines that lie on the same plane. Intersection, the point where 2 lines meet or the line in which 2 planes meet. Vertex is the common endpoint of 2 segments or rays that form the corner of an angle. Now we'll look at a diagram next, and we'll try to make sense of the diagram using these terms. Here's our diagram. There is a plane that is shown in pink. There's a line that does not lie on the plane but intersects it. There are 2 lines that are showing on the plane, and there's a point off of the plane and a bunch of points on the plane. Question number 1, what are 2 ways to label the plane? We can call this plane J, the cursive letter J in the corner, or we can name it by 3 points that lie on the plane that are not collinear, such as points A, C, D, or D, G, K. A set of collinear points in the picture. We have to have 3 or more points that lie on the same line for them to be collinear. So let's use points A, B, and C. Some lines that are shown in the diagram. There are 2 lines that we see that are labeled with a single italicized letter. So we have line H, line I, but we can name a line by 2 points that lie on the line with that symbol above it, line BC. Points that are not coplanar. Now these are 4 points that do not all lie on the same plane. We can say A, B, G, F. Another set of points that are not coplanar are K, E, C, D. The point that 2 lines in the diagram intersect would be point C. Let's move on to postulates. In math, we accept that some statements are true without proof. These are called postulates. So postulates are pieces of information that are accepted as fact. They do not need to be proven. And we have diagrams of 3 pretty famous postulates here. The points postulate is the first one. We'll talk about that in a minute. Intersecting lines postulate is next, and intersecting planes postulate. So let's talk about the points postulate. It says through any 2 points there is exactly 1 line. The intersecting lines postulate says if two lines intersect, then they intersect in exactly one point. That is assuming they're not the same line, of course. Intersecting planes postulate is next. If two distinct planes intersect, then they intersect in exactly one line. So now the difference between a postulate and a theorem. A theorem is a statement that is not just accepted as truth, like postulates. Instead, it must be proven true through a formal method called a proof, which we'll get experience with as the course moves on. A proof is a clear, logical structure of reasoning that has all of those components. You are familiar with a theorem from earlier grades called the Pythagorean theorem. And remember, this has to do with right triangles. And it says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. Or a squared plus b squared, you'll remember, is equal to c squared. So to look at this triangle that's shown, we can use the Pythagorean theorem to prove that it's a right triangle. We'll start with a squared plus b squared equals c squared. And we'll substitute in 5 and 12 as the two legs and 13 as the hypotenuse. Now we can't say equal yet until we work out the math. So 5 squared is 25, 12 squared is 144, 13 squared is 169. But because 169 equals 169, that triangle is in fact a right triangle. So that is an example of a theorem. Now let's match up the terms on the left with either a defined or an undefined term on the right. Remember, a plane is an undefined term. A circle is a defined term. Line is another undefined term. Non-collinear points, even though it has the word point in it, which is an undefined term, non-collinear points is a defined term. And one last example. We are now going to match what's on the left with one of these terms on the right. An angle is a defined term. The a squared plus b squared equals c squared in a right triangle, that's a theorem, right? That's the Pythagorean theorem. A point is an undefined term. And if two planes intersect, then their intersection is a line. That is an example of a postulate.